So for variable initialization, let's take the C code and the Rust code. The right hand side is C code and the left hand side is Rust code. So here if you see, there is a variable that's just declared without any initialization, and there is an attempt made to access this variable without initialization, and such a program in C compiles fine, no problem at all, right? We are all used to that. However, in case of Rust, similar attempt is made. The variable I is attempted to print without initialization. Let's see what happens in Rust. Let's compile the Rust code. So this gives an error. It gives a compilation error. It says, hey, binding I isn't initialized at all. It's declared, but it's left uninitialized. Okay, and it also gives a nice help block here. It says, you can consider assigning a value, something like this. So let's initialize it to say 1. Let's compile the code. So now it prints 1 here. Okay. So now initted, right? Let's say initted. Init. Done. It says init done and it prints 1. So in case of Rust, all variable names require mandatory initialization before access. That's one of the design choices again, and this makes it very safe. So every variable must be initialized before access, and this design choice basically eliminates an entire class of bugs caused by reading uninitialized memory, which is a common source of bugs in C programs. Okay, that is now done, covered. The next one is variable modification. So in case of C, so variables can be modified freely in C, right? So if you see the C code, here, I is now initialized to 10 and there is an attempt to print 10. Okay, so this works fine in C. But in case of Rust, if you try to compile it, it's initially assigned 1 and then try to change to 10. Let's try to print the Rust code first. Same thing. Similarly, we had compiled this. We'll compile this again with the modification and see. It gives a compilation error. It says, hey, you cannot assign twice to an immutable variable. So what does it mean? Cannot assign twice to immutable variable. So it means that all variables by default in Rust are immutable. The word immutable means cannot be changed. So this is also one of the differences between Rust and C. This design choice of Rust prevents accidental modification of values. So, and this makes programs easier to understand. So by default it is immutable or not changeable. In case of C, all variables can be freely changed. So now it also suggested one more thing. It said use the mute keyword if you want to change it. Okay, so saying that, making it explicit, saying, hey, if you want a variable I to change, use mute keyword. So let us use that keyword. Which keyword? Mute keyword. Okay. So if you want a variable to change, you have to use mute keyword. So this is also design difference. And apart from this, this is also a rule of the binding. We discussed some rules, right? We said binding means rules. So some rules like, variables cannot be changed or variables can be changed by mute. is also bound by compiler rules. That's why it's called binding. So this also has many other rules. As we discussed, we'll cover that in chapter 4. Okay, so but here just know that variable changing or variable not changing is also a rule. It's a binding rule. So it's a, this is a mutable binding. The other one was a immutable binding. Now it compiled. Now the value after init is 10. Okay, so this printed fine. So we saw a lot of things today and a lot of design differences in variable initialization. I think we covered for this video.